In this video, you will be familiarized with the accommodation air conditioning system of a cargo ship. A cargo ship's accommodation ventilation system must ensure adequate air circulation to maintain a satisfactory environment in varying weather conditions. For human comfort, the temperature is maintained between 22 degrees Celsius and 25 degrees Celsius, and relative humidity is maintained between 50% and 60%. The system must prevent the spread of fire and be designed with features like insect screens and quiet operation. The system must avoid producing objectionable noises or vibrations. A cargo ship's accommodation air conditioning system uses an air handling unit to condition and distribute air, often employing a single duct system. The air handling unit includes filters, a cooling section, a heating section, and a humidifier. Air is continuously extracted from corridors and passageways of the accommodation through this return duct. Fresh air is drawn through this duct from open atmosphere through an air filter. The air filter prevents dust and vermin from entering the accommodation. Both the return air and fresh air mixes and flows to the air handling unit. The filter in the air handling unit helps prevent clogging of cooling coil and heating coil by filtering the dust particles carried by the air. The cooling system is a direct expansion system of a refrigerant circulated through a cross-fin coil. This section of the air handling unit is used when the atmospheric temperature is more than 20 degrees Celsius. The quantity of refrigerant circulated through the cooling coil is regulated by the expansion valve fitted at the inlet to the cooling coil in the refrigerant line, in such a way that the superheat of refrigerant leaving the evaporator is maintained constantly at the set value of the expansion valve. The compressor is also provided with a capacity control system. The compressor employed in the system has 6 cylinders arranged in W arrangement, 2 cylinders in inline arrangement. When the cooling load is more, all 6 cylinders will be operational. When the cooling load is low in spite of the expansion valve control, the suction pressure in the compressor will fall. This will be sensed by a pressure switch. At the set low pressure, the pressure switch will energize a solenoid valve fitted in the lube oil line to the suction valve lifting unit. Energizing of the solenoid valve will drain the lube oil pressure acting on the valve lifting unit, which keeps the suction valve of 2 cylinders in forced open position to deactivate the compression in these 2 cylinders. Now the compressor will be running only at 66.7% of its capacity. Because the capacity of the compressor is reduced, the suction pressure will go up. If the suction pressure drops despite the cutting off of 2 units of the compressor due to very low cooling load, the second pressure switch will activate another solenoid valve, which will deactivate 2 more cylinders in similar fashion. Now the compressor will be operating at 33.3% of its capacity. The heating section is supplied with saturated steam of 4 bar pressure through a cross-fin coil. This section of the air handling unit is used when outside atmospheric temperature falls below 16 degrees Celsius. The heating coil is fitted with a manual valve for isolation of heating coil at the steam outlet. And inlet lines. Automatic diaphragm-operated regulating valve at the steam inlet line to regulate the quantity of steam entering the heating coil to maintain constant the temperature of the air leaving the accommodation blower. A steam trap also is provided at the steam outlet line to optimize the usage of heat content of the steam in the heating coil. The final section in the air handling unit contains a humidifier. The humidifier is a steam spray type. The quantity of steam sprayed through the nozzles provided in the humidifier is regulated by a diaphragm-operated valve fitted at the steam inlet line so that the humidity of air in the supply duct is maintained between 50% and 60%. The measurement of this is done by a humidistat fitted in the air supply duct to the accommodation. The air is drawn through the air handling unit, brought to the required condition of temperature and humidity, and sucked by the ventilation blower and discharged through a ventilation system to all the rooms. The ventilation duct is a low-velocity single-duct system. The big ventilation duct in the discharge side branches into various small ducts, so that each duct is supplying the air condition to each deck. Each branch is provided with a damper to isolate a deck from supplying air, to prevent fire from spreading through ducts. In addition, each room has an adjustable louver at the air entry point for customized airflow control. Approximately 15% of the air entering the room finds its way into the bathroom through the grill provided at the bottom of the door. The air entering the bathroom is sucked through a duct by a sanitary system exhaust fan and discharged to open atmosphere. Approximately 85% of the air entering the room passes into the passageway through the grill provided at the bottom of the main door. The return air duct picks up this air from the passageway, carries it into the air handling unit. Additional measuring instruments fitted in the system to facilitate an optimum functioning are thermostat at the return air duct, which acts as a control hub to start or stop heating or cooling system for the air. A thermometer at the return air duct. A thermometer at the inlet to the air handling unit. A thermometer at the outlet of the air handling unit. A thermometer at the cooling water inlet to the condenser. A thermometer at the cooling water outlet of the condenser. A pressure gauge at the cooling water inlet to the condenser. A compound gauge at the refrigerant suction to the compressor. A pressure gauge at the refrigerant discharge from the compressor. A pressure gauge for the lube oil of the compressor. A differential pressure switch to stop the compressor at low lube oil pressure. A pressure switch in the discharge side of the compressor to trip the compressor due to high pressure. A pressure gauge at the steam inlet to the heating coil. I hope in this video you get familiarized with the accommodation air conditioning system of a cargo ship. Thanks for watching, and don't forget to subscribe our channel for more education content.